We're going to work on set 2.4 today, and today's actually very, very simple, but it's a key piece to solve quadratics that we're going to do in the next couple sections. So if I had an equation, x, let's say 3x plus 5 equals 0, we've been solving these for years, and notice that it is x to the first. And because it's x to the first, that means there's only one answer. Okay? And to solve this, you would subtract 5, and 3x is equal to negative 5, and then you divide by 3, and x is equal to negative 5/3. Okay? All right. Now, what if I had the equation x squared minus 6x? Now I have an x to the second. And that tells us that there are two answers. Okay? And we're not really going to solve something like this today. We're going to solve a slightly simpler version, but the whole point here is to solve this. Well, can I pull anything out? An x. And I end up with x times x minus 6. Okay, oh, and this is supposed to be equal to 0. Sorry. Okay. Now, kids make mistakes on these problems all the time. And they're very, very simple to solve. You just have to remember what's going on. If I had a times b equals 0, what can you tell me about a and b? They're multiply together, and do both of them equal 0? We're not really sure, right? If a is 7 and b is 0, is that equation true? Yes. If we flipped it, if a was 0 and b was 7, is it true? Yes. What if they're both 0? Then it's still true. So when we look at this, a equals 0, or b equals 0, or both, right? Either a equals 0 or b equals 0 or both. There's no way to know. Yes. Okay. Okay, we'll get to that in just a second. Does everybody understand the A-B idea? Now, let me blend it into the one above. Okay. This is A. And this is B. Does that make sense? Because I just have a multiplication here. I have x times x minus 6. So I could call this A and I could call this B. Well, because that equals 0, I have a multiplication that equals 0. Either A equals 0, or x equals 0, or B equals 0, so x minus 6 equals 0. Well, the first one's already done, x equals 0. The second one, what do I need to do to solve for x? Add 6, and x equals negative 6. So what that's telling me is this equation, this equation has two answers, 0 or negative 6. Okay. Well, what happens when we plug those in? I'm going to plug in 0 here and here. 0 squared, 0, minus 6 times 0 is 0, equals 0. Is that true? Yeah. So x equals 0 is an answer to this equation. What about negative 6? Plug in negative 6. Negative 6 squared is 36. Oh, the answer is positive 6. Sorry. So 6 squared is 36 minus 6 times 6, negative 36. So 36 minus 36 is 0. So x equals 6 is an answer. Do you guys understand that? Now, what you don't need to get today is this step here. Okay? All you need to understand is, how do I turn this into those? Okay, so let me show you another one. X minus 5 times x plus 1 equals 0. So basically, I have a times b equals 0. So either a is 0, or b is 0, or both. Okay? Well, and you need to show your work like this. X minus 5 equals 0. X plus 1 equals 0. I solve the first one by adding 5, and I get x equals 5. I solve the second one by subtracting 1, and I get x equals negative 1. Okay, so those are the answers, 5 and negative 1. Watch what happens when I plug those in. So let's plug in 5. 5 minus 5 is 0 times 5 plus 1 is 6. True. Watch what happens when I plug in negative 1. Negative 1 minus 5 is negative 6 times negative 1 plus 1 is 0. Yes, but not always. In this case, right, you can just change the signs. Okay, let me get to that in just a second. Now, this right here, if I multiply it together, I get x squared minus 4x minus 5. Okay? Any x squared graph looks like this. The only difference is they get moved around. Okay? Well, these numbers here happen to be the places where the graph hits the x-axis. So it would be something like this. So that equation is a U-shaped graph we call a parabola. And that parabola hits the x-axis twice. And it hits the x-axis at negative 1 and at positive 5. So if I were to graph this equation in a calculator, I would get this. Now the hard part is taking this equation and creating that equation. That's tricky. But once you have this equation, finding where it hits the x-axis is super easy. And you might say, just change the signs. But the problem is sometimes that doesn't work. And I'll show you an example here in just a minute. So what I want you to do every time is take this, set it equal to 0, and solve. Because on the harder problems, if you skip that step, you're going to get the wrong answer. Okay? Now, these points are called zeros because that's where the graph is equals 0. They're also called roots. And I will be using those terms interchangeably. I'll call them the roots or the zeros. I could also call them solutions or the answers. But you need to understand how roots work or this class is going to be really difficult. Okay, let me give you another example. 3x plus 1 and 2x minus 5. How do I solve this? I take each set and I write equals 0. 3x plus 1 equals 0 and 2x minus 5 equals 0. Now can I just change the sign? No, it's more complicated than that. So what do I do? Subtract 1. So 3x equals negative 1. And then divide by 3. So x equals negative 1/3. So I don't want you to memorize the change the sign thing. I do want you to memorize the set it equal to 0. You could, right. So we add 5 and then divide by 2. X is 5 halves. And eventually we'll do this enough that you can just do them in your head. But today you need to show your work. Okay? All right. Let's look at your assignment. Okay, what if I had this? So I would get x minus 5 times x, oh, and it equals 0, sorry. Do I really need both of them? No. What are the answers? X equals 5 and 5. Do I need to list it twice? No. Yes. Yeah, so you would write x minus 5 equals 0, and then add 5, and then you get this. It happens twice. Okay. What if I had equals 0. Thank you. I just have 3 answers. So I need to write x minus 3 equals 0, 2x minus 1 equals 0, 7x plus 14 equals 0. Well, the first one, I just add 3. The next one, I add 1 and then divide by 2. And then the last one, I subtract 14 and divide by 7. And I get x equals -2. Now, you can write x equals 3, x equals 1/2, and x equals -2. If you're lazy like me, which I assume you are, you can just do this. Just separate them by commas. All right. Yeah. All right. What about this? What if we had 8x minus 16, or 8x squared minus 16x equals 0? This is not set up like the other problems. Right. I need to create the parentheses. Can I pull anything out? What number goes into 8x squared and into -16x? 2 does? 8 does. 8's the biggest one. So I'm going to yank out 8x. And what's left? X minus 2. No, the x came out. Right? I took out the 8 and the x. So now I can write equals 0 on both of these. Well, 8 times what equals 0? 0. So the first one is 0. And then the other one we add 2. And I get 2. Okay? So let's do 4x squared minus 2x equals 0. What can I pull out? 2x. And what's left? So I take a 2 out of the 4, and I get 2. I take an x out of the x squared, so I get x. Minus, I take the 2 out, what's left? 1. I take the x out, so it's just 1. Then I write equals 0. The first one is just x equals 0. The next one we add 1 and divide by 2. All right? Get to work. 3 through 37, I believe. It's 2.4, whatever page 2.4 is. 3 to 37 odd.